Alright everyone, I wanted to give my next update, and on this one I'm going to be talking about the coding for our little gardener here. So what I've got here is just a blank template that I'm going to start coding with. But the first thing that I like to do is, every board that I'm going to use, the first thing I do is I always load up the Arduino Blink example. Nothing fancy. I go and I pick my new board. I actually had to add in new libraries to have the Nano 33. I find it on my COM port, and then I just upload it. And the reason I do this is because it's a quick check to make sure that the Arduino IDE can communicate with the board. And so you can see there are status LEDs just sitting there blinking away. And that's really all we wanted to do. This proves that we're communicating with the board. Okay, so I open up the serial monitor, and you can see it's just printing out a number for me. And I didn't do a good clean dividing like I wanted to, but we'll go back and fix that. So you see this number, it's varying a little bit. That's just because there's variations within the circuit. There's always going to be a little bit, but we're connected to ground here. Now, one thing I noticed while connecting these is the notes I made based off the pinout diagram are incorrect. I had to go back and check, did I write it down incorrectly, or was that pinout incorrect? But the thing was, my notes say 5 volts should have been on pin 12. This is pin 12. It's not 5 volts. Over here where it says VN is 5 volts. So it's outputting 5 volts on the input pin. So there's some labeling issues here. Not sure what's going on there. But we've got our circuit connected, and if we look here, when our probes have no connectivity, means dry condition, we have a value of 0. Once we get some current flow, my body provides the connectivity, I get a value. Now, if we remember from my other video, when we were messing with these, my hands provided about the same resistance as soil. Slightly less. So we're seeing numbers in the 2, 3, 4s, maybe 500. Look, I can get it up to 600 if I force it. But when we cross it, we should get the full resolution of the ADC, which 1023 is the number we get out. So 1023, actually, we'd consider that saturated, but that would actually be an ideal connection. As you can see, metal on metal, conductor to conductor. Water's not going to give us that ideal connection. So our numbers, even with fully saturated soil, we're probably not going to see numbers that high. We're probably going to be looking in the 200 to 900 range is what I'm guessing. But it works exactly as expected, and literally we have 2 cheap off-the-shelf components and some nails, and then just some wire. This, you could have any cheap wire, you can solder to this, you can solder to that. The goal is to make something cheap, so that's why we did this. So now we need to make these numbers mean something. So that's the next step.